Hello and welcome to Unit 4, which starts with Step 14. All of Unit 4, we're going to stay in triangles and do a whole bunch of stuff, different types of things with triangles. But first, we're going to start by talking about angles of triangles here in Step 14. So hopefully this is a little refresher maybe. But the three angles of a triangle will always have a sum of 180 degrees. So you always want to say that the sum is when we add. So that means that the three angles will always add to 180 degrees, okay? No matter if this is a right triangle or acute, obtuse, scalene, isosceles, equilateral, all three angles in any triangle will always add up to 180 degrees, okay? So that's super helpful when we're trying to find missing angles, because if we have two angles of a triangle, we can always find the third. So in this example, we have so the diagram shows the path of the ball, and we are finding the measure of each numbered angles. So just a quick reminder, the numbered angles are the numbers that do not have the little degree symbol, this circle symbol. Okay, so this is a 20-degree angle, this is a 78 and a 61 degree. The 3, the 2, and the 1 are simply just naming those angles, but are not telling you that they're 1, 2, and 3 degrees. Okay, so my first helpful hint to you would be when we're looking for angles in a triangle, sometimes these are called angle chasers. We like to look for triangles where we already have two angles and we are just simply finding the third. So if you haven't noticed already, this top triangle here, we already have two angles here and we just need that third one. So if we add 78 and 20 together, we'll see that that's 98. When we subtract that from 180, we're left with 82. So that means that the measure of angle 3 is 82. Once you figure out an angle, definitely go ahead and label it so that you remember that that's information that you have. Sometimes you'll need to find these in order, okay? Or it might ask you specifically to find them in a certain order, then you need to do that. Other times we don't need to do that because, for example, here, if we were trying to locate angle 1, all we know about angle 1 is it's in this other triangle here, down here. We only have angle 61, so there's no way we could have started finding 1 first, okay? So from here, since we already just established we can't find 1, let's see if we can find 2. Okay, so angle 2, maybe you can see it already, but we have this X here. This diagram kind of looks like a bow tie figure, like a lopsided bow tie, but we have this X here in the middle. And whenever we see an X with angles across from it, we know that these are vertical angles. Whoops. Okay, so we know this angle from ACB and angle 2 are vertical angles. And if you remember from, I know we haven't talked about vertical angles in a while, but vertical angles are congruent to each other. So angle 2 is also 78 degrees. And we can label that. Okay, so then now we have two angles in this bottom triangle. So we can take those two measurements, add them together, we'll get 139. Subtract that from 180. Borrow, so 41. So the measure of angle 1 would be 41 degrees. Okay. So I'm going to skip the next couple just so you can have them or we can do them in class together. And we're going to talk about a different look for angles, a different kind of shortcut that might help you. So in any triangle, just like we had way back in Unit 1, we talked about interior and exterior angles. We have the same thing for triangles. We have interior angles that happen on the inside of our triangle, and we have exterior angles that happen on the outside. Okay, so we have this is a really nice to know shortcut if you remember it and see it, but again, not something that you necessarily have to use, and I can show you kind of the workaround if you forget this, okay? So it says that the measure of an exterior angle, okay, so the exterior angle here is going to be angle 1, right? It's on the outside of our triangle. So the measure of angle 1 is equal to the sum of the measures of the two remote interior angles, okay? So think about remote interior. We can kind of break this down and figure out what it means without actually knowing what it means. So if you think about something that's remote, okay, maybe it's something outside of a little town, or maybe you live way out far in the suburbs, right? Something that's remote is not close to anything that we are talking about. Okay, it's probably far away. So remote, we're gonna think about this as far away, but it's also interior. So it's far away from our exterior angle, but it's also inside of our triangle. So our two remote interiors here are angle A and angle B. Okay, we're not going to look at C because, again, we want remote. C on this side is interior, but it's right next to the exterior angle, so we're not going to use that. Okay, so if we add up these two angles that are far away from our exterior, we would get angle 1. And we know 1 is an exterior because we've just extended this bottom side and created that exterior angle. Okay, so if we look at our example, it says find the measure of JKL. So JKL, if you remember, we're going to start highlighting at J, go to K, and then up to L. So we're looking for this exterior angle, okay? We want the measure of it, which means we're actually going to find a number. So before we can do that, hopefully you noticed we have variables here. So we're going to have to find X first and then plug it back in. So JKL would be our exterior angle. Our two remote interiors would be up here at L and down here at M. Okay, so if we add the two remote interiors together, their sum is equal to that exterior. So X plus 50 or 50 plus X is equal to 2X minus 15. Okay, and then we can go ahead and just solve this. And 15. So we get 65 for X, but again, remember we have to plug it back in. So JKL was 2X minus 15. So 2 times 65 minus 15. I think we can do a little bit of mental math here. 2 times 65 is 130 minus 15 would be 115. That would be our final answer. Okay, so if you forgot this, and that's okay if you did, because we're just learning, right? We could also think about that if we're looking at this angle JKL on the exterior, we also have, we highlighted this other angle right here, okay? And the yellow angle and the green angle together form a line. We would call that a linear pair. But a linear pair always adds to 180. So if we wanted to figure out what the green angle was, we could take 180 and subtract that angle, and we would get the green angle. And then we could do the green plus the two blue would add up to 180 for our missing to find X if we wanted to do that too. So kind of a workaround if you don't want to use that shortcut, you can always find that interior angle and then go from there. All right, we got one more thing to kind of talk about and then we'll be done with this video. Okay, so a corollary is just another name that it's just another way to say like theorem or postulate. They all kind of mean the same thing. Corollaries are usually shorter, but just kind of a postulate or a theorem that you can use. So it says the acute angles of a right triangle are complementary. Okay, so that makes sense because if we've already used up 90 for angle C here in this diagram, that means that if we took 180 and we subtracted 90, we would have 90 left to share between A and B, because remember, complementary means that they add up to 90 degrees. Okay? Also, there can be at most one right or obtuse angle. Okay, remember right was 90. Obtuse is greater than 90. Okay, but only one right or one obtuse. Okay, now we're just going to do a little angle chaser here and see if we can find all of these angles. Okay, so again, we don't necessarily have to find them in order. If you want to find them in order, just so it's easier to keep track for you, feel free. I'm just going to start with one because there's a whole lot going on here, but no need to start with one. If you recognize something differently, you can start in a different location. So for me, if I take a look at angle 1, I can see that angle 1 is in this triangle here. And I can see that I have two angles already, right? I have this 52 and I have this as a right angle. So if I add 52 and 90 together, I get 142. Subtract that and I get, what, 38? So I know angle 1 is 38. Also, a friendly reminder, whenever you find anything, make sure you label it so that you know that you can use that for future angles. So angle 1 is 38. Okay, just if we want to move in angle order, we can see that angle 2 is a part of this triangle here. Again, we have a right angle right down here. We know that because of that little box. We have an angle 38 and a right angle, so I'm going to add those together. 128, subtract it from 180, 52, and the measure of angle 2 is 52 degrees, and I'm going to go ahead and label that. Okay, so just moving in order, I'm going to try to find angle 3 here. Okay, angle 3, if you notice, is part of this right angle with angle 2. So that means that angle 2 and 3 are complementary. They would create a 90-degree angle together. So if we just subtract the 52 that we've already used, we can see that the measure of angle 3, is 50 or 38. What am I saying? 38. Okay, and then last but not least, we would have to find angle 4. So angle 4, we could do this a couple different ways. We can see that this shape, this big shape, is a rectangle. Okay, so this angle up here should also be right. So 1 and 4 together are creating a right angle. The other way you could think about it is right here in this middle piece, we have a straight line. If this side is 90, this side is also 90, and we can see that then we would have two angles of this triangle. I'm just going to go ahead and use that right angle, take a little step out for ourselves. So 90 minus 38, we get 52, and angle 4 is 52. Okay, and that is part 1 of step 14. Thanks for watching.